October 24th, 1944. The Sibuyan Sea, Philippines. A single ship absorbed 19 torpedoes and 17 direct bomb hits from 259 American aircraft over the course of one brutal day. 19 torpedoes, 17 bombs. That is more punishment than any warship in human history had ever endured. And yet for hours, she refused to sink. Her name was Musashi, the mightiest battleship the Empire of Japan ever built, a 73,000-ton steel fortress armed with the largest naval guns the world had ever seen. But here is the part they never told you. The man who helped seal her satisfying fate was not some decorated admiral or a West Point genius. He was a 23-year-old aircraft mechanic from rural Kansas named Dale Birchfield. A farm boy who once fixed tractor engines in wheat fields and now found himself tightening torpedo mounts on TBF Avenger bombers aboard the USS Intrepid somewhere in the Philippine Sea. Dale had never seen a battleship in his life before the war. He had never fired a weapon in combat. But on that October morning in 1944, the torpedoes his hands had prepared would strike the most heavily armored warship ever constructed and help send over 1,000 men to the bottom of the Pacific. This is the story of how that happened. This is the story of how the most expensive, most powerful, most feared battleship Japan ever built was destroyed not by another battleship, but by waves of screaming aircraft piloted by farm boys, college dropouts, and former grocery clerks. And it all started with one of the most ambitious and secretive shipbuilding projects in naval history. Nagasaki, Japan, 1937. The world was on the edge of catastrophe. In Europe, Adolf Hitler was rearming Germany at a terrifying pace. In Asia, Imperial Japan had already invaded China and was rapidly expanding its military reach across the Pacific. The Japanese High Command knew that war with the United States was not a question of if, but when. And they knew something else. They could never match American industrial power. The United States had more steel mills, more shipyards, more factories, and more workers than Japan could ever hope to mobilize. In a prolonged war of production, Japan would lose. Period. So the Imperial Japanese Navy came up with a different philosophy. If they could not build more ships than America, they would build bigger ships. Ships so massive, so heavily armed, and so thickly armored that each one could take on 2 or 3 American battleships simultaneously and win. This was not arrogance. This was mathematics. Japanese naval planners calculated that a single super battleship displacing over 70,000 tons and carrying 460mm guns could outrange and outfight any vessel the United States Navy possessed. The Americans had nothing that could match those guns, nothing that could penetrate that armor, nothing that could even get close enough to fight on equal terms. And so, in the utmost secrecy, Japan began constructing 2 of these leviathans. The first was Yamato. The second was Musashi. Together they would form the backbone of a fleet designed to smash the American Navy in one decisive battle and force Washington to negotiate peace. That was the plan. What actually happened was something no one in Tokyo could have predicted. Nagasaki Shipyard, November 1st, 1940. The day Musashi slid into the water for the first time, not a single foreign intelligence agency knew she existed. Think about that for a moment. A ship longer than 2.5 football fields, wider than a 4-lane highway, and heavier than a small town was built right across the bay from the United States consulate in Nagasaki, and the Americans had absolutely no idea. The level of secrecy was extraordinary. Giant tarps were draped over the construction site. Trees were planted to block sightlines. Workers were forbidden from speaking about the project even to their own families. The dry dock itself had to be completely rebuilt and enlarged, because no existing facility in Japan was big enough to hold Musashi's hull. When she was finally launched, she was the second largest moving object ever created by human hands. Her statistics were staggering. Length of 263 meters. Beam of 39 meters. Full load displacement of approximately 73,000 tons. Her 3 main turrets, Each housed three 460mm Type 94 guns, the largest naval guns ever mounted on any warship in history. Each gun could hurl a shell weighing 1.5 tons to a distance of nearly 40 kilometers. Her belt armor was 410mm thick. Her turret faces were protected by an almost unbelievable 650mm of hardened steel. Her deck armor measured between 200 and 230mm. She was in every measurable sense the most powerful surface warship the world had ever seen. And she was beautiful. Officers who served aboard her later described the interior as a labyrinth. The corridors were so long and so numerous that new crew members routinely got lost. Engineers eventually posted directional arrows on the walls just so sailors could find their way to their stations. The ship carried a crew of nearly 2,400 men. She had her own hospital, her own bakery, her own machine shops. She was a floating city built for one purpose and one purpose only: to destroy the American fleet. Truk Lagoon. Early 1943. Musashi was commissioned in the summer of 1942, just months after the disaster at Midway had cost Japan 4 fleet carriers and shifted the momentum of the Pacific War firmly in America's favor. From the very beginning, Musashi's career was marked by a strange and deeply frustrating paradox. She was the most powerful warship afloat, yet she had nothing to fight. In early 1943, Musashi was designated the flagship of the combined fleet. Admiral Isoroku Yamamoto himself raised his flag aboard her, a fitting honor for the mightiest ship in the Japanese Navy. But the war had already changed in ways that made Musashi's enormous guns almost irrelevant. The great surface battles that Japanese planners had envisioned simply never materialized. Instead, the Pacific War was being decided by aircraft carriers, submarines, and island-hopping campaigns that bypassed Japanese strongholds entirely. Musashi sortied repeatedly from Truk Lagoon throughout 1943, steaming out with impressive task forces to intercept American carrier groups. Every single time, she returned without firing a shot. In October 1943, intelligence reports indicated that U.S. carriers were preparing to strike Wake Island. Musashi immediately led a powerful force to intercept. The fleet sailed for days, burning precious fuel that Japan could barely afford to waste. The American carriers never appeared. Musashi turned around and sailed back to Truk. Again, not a single shell fired. By the end of 1943, the most expensive warship Japan had ever built had not engaged a single enemy vessel. Not one. She sat at anchor in Truk Lagoon week after week, her massive guns pointed at empty ocean, her crew growing restless and demoralized. And then came the humiliation that cut deepest of all. Early 1944. The Western Pacific. As Japan's strategic situation deteriorated, the High Command began using Musashi for something no one had ever imagined when she was designed. They turned her into a transport ship. The mightiest battleship in the world, armed with the largest guns ever built, protected by the thickest armor ever fitted to a warship, was now ferrying troops and supplies to isolated island garrisons. Crates of rice and ammunition were stacked in her hangars. Soldiers crowded her decks. Her officers were furious. This was not what Musashi was built for. This was not what they had trained for. But orders were orders, and Japan was losing the war. March 29, 1944, near Palau. Musashi's first wound came not from the sky or from an enemy battleship, but from below the surface. The American submarine, USS Tunney, was patrolling near Palau when her captain spotted the massive silhouette of Musashi through his periscope. He could hardly believe what he was seeing. Tunney launched a spread of torpedoes. One struck near Musashi's bow. The explosion was tremendous. The entire ship shuddered. Damage control teams rushed forward to find a massive hole torn in the bow plating. Seawater poured in. The thick armor belt had held, but the unarmored bow section was badly compromised. Musashi limped away from Palau and made the long, painful journey back to Japan for repairs. During the refit at the shipyard, engineers rebuilt the damaged bow and made a critical decision. They dramatically reinforced Musashi's anti-aircraft defenses. Dozens of additional 25mm guns were installed across the ship. By the time the work was complete, Musashi carried over 100 anti-aircraft weapons. The reason was simple. Everyone now understood that the greatest threat to the ship came not from enemy battleships or even submarines. It came from the sky. American air power was growing exponentially. New carriers were entering service every few months. New aircraft were faster, tougher, and carried heavier ordnance. The pilots flying them were superbly trained. Japan's own naval aviation, by contrast, had been virtually annihilated. June 1944. The Battle of the Philippine Sea. This was supposed to be Japan's chance to turn the tide. Instead, it became a massacre. American F-6F Hellcat fighters, working in coordination with fleet anti-aircraft fire, destroyed what remained of Japan's carrier aviation in a single engagement so lopsided that American pilots called it the Great Marianas Turkey Shoot. Musashi was there. She sailed with the Japanese surface fleet. She watched Japanese aircraft fall from the sky in flames by the dozens. And once again, she did not fire a single round from her main guns. After the Philippine Sea, the Imperial Japanese Navy was left with fewer than 100 fully trained carrier pilots. The number of operational aircraft carriers could be counted on one hand. The surface fleet, including Musashi, was now forced to operate in waters completely dominated by enemy air power with virtually no air cover of its own. The stage was now set for the final act. But the men in Tokyo had one last desperate plan. A plan so audacious, so reckless, and so utterly suicidal that even some Japanese admirals questioned whether it could work. They called it Operation Shogo, and Musashi was at the very heart of it. In Part 2, we will follow Musashi into the Sibuyan Sea on the morning of October 24, 1944, when 259 American aircraft descended on her like a swarm of angry hornets. We will see what happens when the largest battleship ever built faces the full fury of American carrier aviation. And we will learn what happened to Dale Birchfield, the Kansas farm boy whose hands prepared the torpedoes that helped kill a giant. The clock is ticking. The planes are already in the air. October 24, 1944, 5:47 a.m., aboard USS Intrepid, somewhere in the Philippine Sea. In Part 1, we met Musashi, the most heavily armored battleship ever built, a 73,000-ton monster that had spent 2 years waiting for a fight that never came. We met Dale Birchfield, the Kansas farm boy turned aircraft mechanic, whose hands would help prepare the weapons that brought her down. And we watched as Japan launched Operation Shogo, a desperate suicidal gamble to stop the American advance in the Philippines. But here is what we did not tell you. Before a single torpedo could be dropped on Musashi, before a single bomb could crack her deck, the United States Navy had to solve a problem that nearly destroyed its own ability to sink battleships from the air. A problem so deeply embedded in the institution that it almost cost America the Pacific War. In 1942, American torpedo bombers had a kill rate against enemy capital ships of less than 3%. 3%. 97 out of every 100 torpedoes launched against Japanese warships either missed, malfunctioned, or failed to detonate. The torpedo, the one weapon that could sink a battleship, simply did not work. And the worst part was that almost nobody in charge wanted to admit it. And this is where everything got worse. Bureau of Ordnance, Washington, D.C., January 1943. The problem with American torpedoes was not a secret. It was a scandal. Submarine commanders in the Pacific had been reporting catastrophic torpedo failures since the first month of the war. Torpedoes that ran too deep. Torpedoes that veered off course. Torpedoes that struck their targets dead on and simply bounced off without exploding. The Mark 14 torpedo, the standard weapon carried by American submarines and many torpedo bombers, was riddled with defects. Its magnetic detonator was unreliable. Its contact detonator was fragile. Its depth-keeping mechanism was wildly inaccurate. Submarines were firing full spreads of 6 torpedoes at stationary targets and getting 0 hits. Pilots were flying through walls of anti-aircraft fire to drop torpedoes that tumbled uselessly into the sea. The human cost was horrifying. At the Battle of Midway in June 1942, Torpedo Squadron 8 launched 15 TBD Devastator aircraft against the Japanese carrier fleet. All 15 were shot down. Only 1 pilot survived, and not a single torpedo hit its target. 15 planes. 29 men dead. 0 results. Across the Pacific Fleet, torpedo bomber crews were calling their own weapon the Mark 14 coffin maker, because it was more likely to kill them than the enemy. Formal complaints flooded up the chain of command. Submarine skippers wrote furious after-action reports. Squadron leaders demanded investigations. And the Bureau of Ordnance in Washington, the department responsible for designing, testing, and supplying every torpedo in the United States Navy, responded with something remarkable. They did absolutely nothing. The Bureau insisted the torpedoes worked perfectly. They blamed the crews. They blamed the pilots. They blamed poor aim, bad tactics, incompetent captains. Rear Admiral William Blandy, who oversaw the Bureau during this period, dismissed the complaints as exaggerations from combat-stressed officers who simply could not shoot straight. Internal memos circulated claiming that the Mark 14 had passed all factory tests with flying colors. The fact that it was failing catastrophically in actual combat was, according to the Bureau, the fault of the men using it, not the weapon itself. This was not just bureaucratic stubbornness. This was institutional arrogance on a scale that was costing American lives every single day. But one man refused to accept it. Pearl Harbor Naval Shipyard. March 1943. His name was Captain Charles Mommsen. He was not a politician. He was not a desk officer. He was a submariner, an engineer, and a man who had already done something the Navy considered impossible. Back in the 1930s, Mommsen had invented a revolutionary escape device for trapped submarine crews, the Mommsen lung, after watching helplessly as 40 men died in a submarine accident because no escape equipment existed. The Navy had initially rejected his invention. They told him it was unnecessary, impractical, and a waste of resources. Mommsen built prototypes in his own workshop. He tested them on himself. He nearly drowned twice during development. And eventually, the Navy adopted the Mommsen lung as standard equipment on every submarine in the fleet. It saved hundreds of lives. Now in early 1943, Mommsen was stationed at Pearl Harbor as a torpedo specialist, and he was furious. He had access to the after-action reports. He had spoken with submarine captains returning from combat patrols. He knew the torpedoes were defective, and he knew the Bureau of Ordnance was lying about it. "We are sending men to die with weapons that do not function," Mommsen wrote in a private letter to a colleague. And the people responsible for those weapons refused to look at the evidence because it would mean admitting they were wrong. Mommsen requested permission to conduct independent torpedo tests at Pearl Harbor using live warheads against real targets. The Bureau of Ordnance denied his request. They said it was unnecessary. They said the torpedoes had already been tested extensively at their facility in Newport, Rhode Island. They warned Mommsen that pursuing unauthorized testing could result in formal disciplinary action. Mommsen requested again, denied again. He requested a third time, this time routing his appeal through Admiral Chester Nimitz's office. The Bureau told Nimitz's staff that Mommsen was a known troublemaker with a history of insubordination. But Mommsen had something the Bureau did not expect. He had an ally. Admiral Charles Lockwood, commander of the Pacific Submarine Fleet, had been receiving the same complaints from his own captains. Lockwood was a quiet, methodical man, not the type to pound tables or shout at superiors. But he was also a man who kept meticulous records, and those records showed a pattern that was impossible to ignore. Of the last 800 torpedoes fired by Pacific Fleet submarines, fewer than 30 had detonated properly. That was a functional failure rate of over 96%. Lockwood did not need anyone to tell him the torpedoes were broken. He had the numbers. And when Mommsen approached him with a plan for unauthorized testing, Lockwood made a decision that could have ended both their careers. "Do it," Lockwood said. "Test them. Find out what is wrong. And do it before I lose another boat." The date was set for June 20th, 1943. They would have exactly 1 day. If the results were inconclusive, there would be no second chance. Kahulaway Island, Hawaii, June 20th, 1943. The morning was overcast. A light wind blew from the northeast. Mommsen had arranged for a series of live fire tests using Mark 14 torpedoes, launched from both a submarine and a modified torpedo bomber against a cliff face on the uninhabited island of Kahulaway. The targets were steel plates welded to the rock, designed to simulate the hull of a Japanese warship. Observing from a safe distance were Lockwood, several submarine captains, and 2 deeply skeptical representatives from the Bureau of Ordnance who had been invited specifically so they could not later claim the tests were fabricated. The first torpedo was launched from the submarine USS Muskalunge at a range of 900 yards. It ran straight. It hit the steel plate dead center. The warhead did not explode. A dull metallic clang echoed across the water. Silence. The second torpedo was launched. Same target, same range. It struck the plate at a slight angle. Again, no detonation. The torpedo crumpled against the steel like a tin can thrown against a brick wall. The Bureau representatives shifted uncomfortably but said nothing. The third torpedo was launched. This time it veered sharply to the left, missed the target entirely, and buried itself in the sand 200 yards down the beach. Mommsen ordered the unexploded torpedoes recovered. When his team disassembled the warheads, they found the problem. The contact detonator, the firing pin mechanism, that was supposed to trigger the explosion on impact, was so poorly designed that it jammed on direct hits. The harder the torpedo struck, the more likely the firing pin was to crumple instead of firing. In other words, a perfect shot was almost guaranteed to fail. Only a glancing blow, an imperfect hit at an oblique angle, had any chance of detonating the warhead. The weapon was literally designed to fail when it worked correctly. Mommsen documented everything: photographs, measurements, recovered components, detailed technical analysis. He presented the findings to Lockwood that evening. Lockwood stared at the data for a long time. Then he picked up the phone and called Admiral Nimitz directly. "Sir," Lockwood said, "I have proof." Within 48 hours, Nimitz ordered the Bureau of Ordnance to redesign the Mark 14 contact detonator immediately. The Bureau resisted. Nimitz overruled them. New detonators based on a simpler, more robust design were rushed into production at Pearl Harbor's own workshops, bypassing the Bureau entirely. Submarine crews and torpedo bomber squadrons began receiving modified torpedoes within weeks. The results were immediate and devastating. In the 3 months before Mommsen's tests, Pacific Fleet submarines sank an average of 12 Japanese ships per month. In the 3 months after the new detonators were installed, that number jumped to 43 ships per month, a 258% increase. Torpedo bomber kill rates against enemy warships rose from under 3% to nearly 14% by early 1944, and continued climbing as further modifications were made. American submarines, once frustrated and demoralized, became the deadliest predators in the Pacific. By the end of 1943, they were sinking Japanese merchant ships faster than Tokyo could build replacements. But convincing the Navy to fix the torpedo was one thing. Getting the fix to every squadron, every submarine, every carrier air group across a war zone spanning millions of square miles of ocean was something else entirely. Old torpedoes were still in warehouses across the Pacific. Supply officers who had not heard about the modifications continued issuing defective weapons. Some commanding officers refused to believe there had ever been a problem and rejected the new detonators. Mommsen spent months traveling from base to base, ship to ship, personally demonstrating the difference between the old and new designs. He carried a defective firing pin in one pocket and a redesigned one in the other, showing anyone who would listen exactly why one worked and the other did not. By mid-1944, the transformation was nearly complete. American torpedo bombers were now carrying weapons that actually detonated on impact. Submarine wolf packs were strangling Japan's supply lines, and the Navy was preparing for the largest naval battle in history, a battle that would take place in the waters around the Philippines, a battle where everything Mommsen had fought for would be put to the ultimate test against the largest, most heavily armored target imaginable. Musashi was waiting. But here is what nobody anticipated. When Japanese intelligence learned that American torpedo accuracy had suddenly and dramatically improved, they did not just accept it. They began investigating. By late 1944, captured documents and interrogated prisoners revealed fragments of information about the torpedo modifications. Japanese naval engineers started working on countermeasures, new anti-torpedo baffles, revised evasive maneuvering doctrines, emergency hull reinforcement protocols. And aboard Musashi herself, Vice Admiral Takeo Kurita received a classified intelligence briefing warning that American air-launched torpedoes were now significantly more lethal than they had been even 6 months earlier. Kurita read the report carefully. He ordered additional watertight compartments sealed. He drilled his damage control teams twice a day instead of once. He believed Musashi's armor could still absorb anything the Americans could throw at her. He was wrong. In Part 3, we will follow Musashi into the killing ground of the Sibuyan Sea. We will stand on her deck as 259 aircraft descend from the clouds. We will watch as Dale Birchfield's torpedoes, armed with the detonators that Mommsen fought to fix, slam into her hull one after another. And we will see the moment when the mightiest battleship ever built finally began to die. The planes are fueled. The torpedoes are loaded. The pilots are in their cockpits. And the clock has just struck 10 in the morning. October 24th, 1944. 9:47 a.m. The Sibuyan Sea, Philippines. In Part 1, we watched Japan build the most powerful battleship in history, and then waste it for 2 years guarding empty ocean. In Part 2, we followed Captain Charles Mommsen as he fought his own navy to fix a torpedo that did not work, a battle that nearly ended his career before it saved thousands of lives. And we left Dale Birchfield, the Kansas farm boy, tightening the last bolts on torpedo mounts aboard USS Intrepid as 259 aircraft prepared to launch against the largest, most heavily armored warship ever built. Now the waiting is over. The torpedoes work, the pilots are trained, and Musashi is sailing straight into the kill zone. But the Japanese knew the Americans were coming. Intelligence reports had warned Vice Admiral Kurita that U.S. torpedo accuracy had improved dramatically. He had doubled his damage control drills. He had sealed additional watertight compartments. He believed his ship could survive anything. He was about to find out. Tokyo, Japan, October 1944. The Japanese Naval General Staff was in a state of controlled panic. Over the previous 6 months, American submarines had sunk 274 Japanese merchant vessels and 31 warships. Before the torpedo modifications of late 1943, the average had been roughly 12 ships per month. Now it was approaching 50. Japan's supply lines were being severed one convoy at a time. Oil tankers from Borneo were being picked off before they could reach the home islands. Troop transports were being ambushed in waters once considered safe. The numbers were catastrophic. Admiral Suemu Toyota, commander of the combined fleet, studied the reports and recognized a pattern. American torpedoes were no longer missing. They were no longer bouncing off hulls without detonating. Something fundamental had changed. Japanese naval intelligence confirmed it in September 1944, when divers recovered fragments of an American torpedo from a sunken escort vessel near Formosa. The contact detonator was a completely new design, simpler, sturdier, almost impossible to jam on impact. Toyota ordered immediate countermeasures. Engineers began designing new anti-torpedo baffles for capital ships. Evasive maneuvering doctrines were rewritten. Captains were instructed to never present a broadside profile to incoming aircraft. Additional lookouts were posted on every ship specifically to spot low-flying torpedo bombers. But these countermeasures took time to implement. And time was the one thing Japan did not have. When Operation Shogo was launched in October 1944, the Japanese surface fleet sailed with full knowledge that American air-launched torpedoes were now significantly deadlier than they had been a year earlier. Kurita briefed his captains personally. He told them to expect heavy air attacks. He told them damage control would be the difference between survival and destruction. He told them the fate of the empire depended on reaching Leyte Gulf. What he did not tell them was that the odds were almost mathematically impossible. But this was not the only crisis brewing. Aboard USS Intrepid, October 23, 1944, the American side had its own problems. Dale Birchfield and the other mechanics aboard Intrepid had been working around the clock for 72 hours, preparing aircraft for the coming battle. Fatigue was setting in. Mistakes were becoming more frequent. And then, at 11 p.m. on the night of October 23rd, a routine inspection revealed something that sent a chill through the entire torpedo maintenance crew. 3 of the modified Mark 13 aerial torpedoes, stored in the forward magazine, showed signs of a propellant leak. The alcohol-based fuel was seeping from hairline cracks in the combustion chambers. If the leak continued, these torpedoes could detonate prematurely after launch, killing the pilots who dropped them. Or worse, they could explode inside the magazine and take the entire ship with them. Birchfield and his team had less than 8 hours to inspect every torpedo on the ship, identify the defective units, and replace them with spares from the reserve stock. They worked through the night by flashlight in the cramped, stifling magazine below the waterline. By 5 a.m., they had found and isolated 5 defective torpedoes out of 42. The remaining 37 were certified combat ready. It was enough, barely. Some of the pilots did not trust the torpedoes even after the inspection. Lieutenant Commander William Ellis, who would lead the first Avenger strike against Musashi, reportedly told his squadron before takeoff that he wanted every torpedo checked twice and then checked again. "I am not dying," Ellis said, because some factory in Rhode Island cut corners on a fuel seal. Nobody laughed, but there was no more time for doubt. The scouts had found Kurita's fleet, the Sibuyan Sea, October 24, 1944. 10:27 a.m. The first wave appears from the east. 30 aircraft from USS Intrepid, 12 Helldivers, 8 Hellcats, 10 Avenger torpedo bombers. They break through the cloud layer at 12,000 feet, and there it is. Kurita's fleet, 5 battleships, 10 heavy cruisers, destroyers screening on the flanks, and in the center, unmistakable, the largest warship any of these pilots have ever seen, Musashi. She is enormous. From the air, she looks less like a ship and more like a floating island. Her wake stretches white and straight behind her. Her 460mm turrets are already elevated, pointing toward the sky. Over 100 anti-aircraft guns bristle from every surface. The attack begins. Hellcats dive first, strafing the deck to suppress anti-aircraft fire. Tracers crisscross the sky in dense orange webs. Black puffs of flak explode around the diving aircraft. 2 Hellcats take hits. One trails smoke but keeps flying. Then the Helldivers roll in. Near vertical dives from 10,000 feet. The first bomb misses, throwing up a white column of water 50 yards off the port bow. The second hits the forward deck. Steel plates buckle. Smoke erupts. The third bomb strikes near the number 1 turret. The explosion sends debris spinning into the air. Musashi's gunners respond with everything they have. The massive 460mm main guns fire fragmentation shells skyward, each one designed to shred aircraft with thousands of steel fragments. The concussion alone is enough to flip a plane. The sky around Musashi becomes a wall of fire and shrapnel. But the Avengers are already on their run. 10 torpedo bombers drop to wave top height. They skimmed the surface at 200 knots, each carrying a single Mark 13 torpedo fitted with the redesigned contact detonator that Mommsen fought to create. Musashi's captain orders hard starboard to present the narrowest possible profile. The ship begins to turn, but 73,000 tons does not turn quickly. The first torpedo drops. It hits. The water runs straight and strikes Musashi's portside amidships. Detonation. A massive geyser of water erupts against the hull. The ship shudders. The second torpedo hits 30 seconds later. Port side again, further aft. Another explosion. Another shudder. A third torpedo strikes the starboard bow. The impact tears a hole below the waterline. Seawater floods in. This is only the first wave. Over the next 5 hours, 4 more waves of aircraft descend on Musashi. Wave after wave after wave. Pilots from intrepid Essex Franklin and Enterprise take turns attacking in rotation. As one squadron expends its ordnance and turns for home, another appears on the horizon. Musashi fights. She fights with everything she has. Her anti-aircraft guns fire until the barrels glow red. Her damage control teams seal compartments, pump water, shore up bulkheads. Her engineers keep the engines running even as fuel lines rupture and fires break out below decks. Her crew is magnificent. But the torpedoes keep coming, and now they work. By 1 p.m., Musashi has taken 11 torpedoes and 8 bombs. Her speed drops from 27 knots to 18, then to 12. A torpedo strikes the rudder area. Steering becomes difficult. Another torpedo opens the bow. The forward compartments flood. The bow begins to sink. By 3 p.m., the count reaches 19 torpedoes and 17 bombs. 19 torpedoes, each one detonating exactly as designed. Each one tearing another wound in Musashi's hull. The ship that was supposed to be unsinkable is being taken apart piece by piece. At 3:30 p.m., the air attacks finally stop. The Americans have expended their ordnance. Musashi is still afloat. Barely. She is listing heavily to port. Her bow is almost underwater. Fires burn across the superstructure. Her speed is 0. She is dead in the water. The news of the attack reaches fleet headquarters within hours. Admiral Nimitz receives the damage assessment from his carrier commanders. 19 confirmed torpedo hits, 17 bomb hits, and crucially, every torpedo that struck the ship detonated. Every single one. A year earlier, with the old Mark 14 detonators, the probability of even 1 in 3 torpedoes working was considered optimistic. Now, they had a near-perfect detonation rate. Nimitz passes the report to his staff. No one speaks for a moment. Then someone says what everyone is thinking. Mommsen was right. The impact rippled outward like shockwaves from an explosion. Across the Pacific Fleet, torpedo bomber squadrons that had once considered their weapon unreliable now had absolute confidence in it. Submarine wolf packs became even more aggressive, pushing deeper into Japanese-controlled waters. In the 3 months following the Battle of Leyte Gulf, American submarines sank an additional 184 Japanese vessels, a rate that exceeded anything previously achieved. Japanese naval losses in October 1944 alone were staggering. 4 aircraft carriers, 3 battleships including Musashi, 10 cruisers, 11 destroyers. The Imperial Japanese Navy, once the most feared force in the Pacific, ceased to exist as a coherent fighting fleet. It would never recover. For the Japanese sailors who survived the psychological impact was devastating. Captain Toshikazu Omai, a staff officer who witnessed the aftermath of Leyte Gulf, later wrote that the destruction of Musashi shattered something deeper than steel. It shattered the belief that Japan could win. Meanwhile, in the United States, the story played very differently. Newspapers celebrated the sinking of Japan's super battleship as proof of American air supremacy. Newsreels showed carrier aircraft launching from flight decks with triumphant narration. What they did not show was the 2-year struggle behind the scenes to make the weapons work. Mommsen's name appeared nowhere in the press coverage. Birchfield's name appeared nowhere. The men who had fixed the torpedoes inspected them through the night and loaded them onto aircraft in the pre-dawn darkness received no headlines. The Navy, however, noticed. Mommsen was quietly promoted and given command of a submarine squadron. Lockwood received the Distinguished Service Medal for his leadership of the submarine force. The Bureau of Ordnance was reorganized. Rear Admiral Blandy, who had dismissed torpedo complaints for over a year, was reassigned. The Mark 13 aerial torpedo, once mocked as the coffin maker, became one of the most effective air-delivered weapons of the war. By 1945, it had a combat reliability rate exceeding 90%, up from less than 3% in 1942. The war was won not by one decisive weapon or one brilliant idea. It was won because ordinary men like Mommsen and Birchfield refused to accept that a broken system could not be fixed. They pushed. They tested. They risked their careers and their lives. And they changed the outcome of the largest naval conflict in human history. But the story of Musashi does not end at the bottom of the Sibuyan Sea. And the story of the men who sank her does not end with the war. What happened to Dale Birchfield after 1945? What happened to Mommsen? What became of the 1,376 Japanese sailors who survived the sinking? And what did the wreck of Musashi reveal when it was finally found 7 decades later on the floor of the Pacific? This story has one final chapter, and it is the one almost nobody knows. October 24th, 1944, 3:35 p.m. The Sibuyan Sea. Let us remember where we have been. In Part 1, Japan built the most powerful warship ever to sail the ocean and then watched helplessly as it sat idle for 2 years without firing a shot. In Part 2, Captain Charles Mommsen risked his entire career to prove that American torpedoes were broken, and Admiral Lockwood gave him 1 day to prove it. In Part 3, we watched 259 American aircraft descend on Musashi and hammer her with 19 torpedoes and 17 bombs across 5 brutal hours of unrelenting assault. And yet, at 3:35 p.m. on October 24th, Musashi was still afloat. Barely. Bleeding. Burning. But afloat. The air attacks had stopped. The American aircraft had expended their ordnance and turned back toward their carriers. For the first time in 5 hours, the sky above the Sibuyan Sea was silent. But aboard Musashi, silence was the last thing anyone experienced. This is where the story shifts from the attackers to the attacked. From the men who dropped the torpedoes to the men who absorbed them. And what happened in the next 4 hours aboard that dying ship is something the world was never meant to know. Aboard Musashi, 3:40 p.m. Vice Admiral Kurita's fleet had scattered. The other battleships Yamato, Nagato, Kongo, and Haruna had pulled ahead during the air attacks, leaving Musashi behind as she slowed to a crawl. The cruisers and destroyers maintained formation around the healthier ships. Musashi was alone. 3 destroyers, Yukikaze Kiyoshimo and Isakaze, were ordered to stay behind as escorts, circling the stricken battleship like anxious dogs around a wounded master. On the bridge, Captain Toshihira Inoguchi surveyed the damage. The reports coming in from below decks were catastrophic. The bow had sunk nearly 6 meters below its normal waterline. Compartments forward of turret number 1 were completely flooded. Fires burned in at least 4 locations across the ship. The port list had reached nearly 12 degrees and was increasing. 3 of the 4 engine rooms were flooded or damaged. Only 1 propeller shaft was still functional, and it could barely push the 73,000-ton hull at walking speed. The ship's chief engineer, Commander Kato, reported to the bridge at 3:50 p.m. His uniform was soaked with oil and seawater. His hands were burned. He told Inoguchi that the flooding could not be controlled. The pumps were overwhelmed. Water was entering faster than they could remove it. At the current rate, the ship would capsize within 3 to 4 hours. Inoguchi listened without expression. Then he gave an order that stunned the bridge crew. "Set course for Cibolo Island. Maximum speed. We will beach the ship." Cibulo Island was approximately 30 nautical miles to the northwest. If Musashi could reach shallow water, she could be grounded on the bottom, with her deck still above the surface. The crew could survive. The ship's guns could potentially still fire. Even crippled and beached Musashi could serve as a stationary fortress. It was a desperate plan, but desperation was all they had left. Commander Kato returned to the engine rooms and somehow coaxed the remaining machinery back to life. For a brief, extraordinary moment, Musashi began to move again. 6 knots. Not much faster than a man jogging. But she was moving. The men below decks worked in conditions that defy imagination. Engine rooms were partially flooded. The water was black with oil and hot from ruptured steam pipes. Electrical systems sparked and shorted. In several compartments, sailors worked in complete darkness, navigating by touch and memory alone. The temperature in the lower decks exceeded 50 degrees Celsius. Men collapsed from heat exhaustion and were dragged to higher levels by their shipmates. Damage control teams plugged leaks with mattresses, wooden beams, and their own bodies. When shoring timbers ran out, they ripped doors off their hinges and wedged them against cracked bulkheads. One team in the forward magazine discovered that a torpedo hit had buckled the deck above them so severely that the main gun ammunition hoists were jammed. They spent an hour manually moving 1.5-ton shells away from a fire that was creeping steadily closer. These men knew the ship was dying. They did it anyway. But this was not the only battle being fought that afternoon. Above decks, the medical staff was overwhelmed. Musashi's sick bay had been designed to handle perhaps 30 or 40 casualties at a time. By 4 p.m., there were over 400 wounded men spread across every available space. The ship's corridors were lined with injured sailors. Some had shrapnel wounds. Some had severe burns from fires and steam. Some had been thrown against bulkheads by torpedo impacts so violently that their bones had shattered. The ship's senior medical officer, Surgeon Commander Ishino, performed amputations and emergency surgeries on a table that tilted more steeply with every passing minute as the list increased. His assistants held patients down by hand because the restraining straps could no longer keep them on the angled surface. Morphine ran out by 5 p.m. After that, surgeries were performed with nothing but a leather belt for the patient to bite on. But even as the medical teams fought to save the living, something else was happening aboard Musashi. Something quieter and far more profound. 5:15 p.m. The officer's wardroom. Captain Inoguchi had retreated briefly to his cabin. He wrote 2 letters. The first was to Admiral Toyota at Combined Fleet Headquarters. It was his final situation report. Factual, brief, professional. He reported the ship's condition, the number of casualties, and his intention to beach the ship if possible. He concluded with a single sentence that has since become one of the most quoted lines in Japanese naval history. Musashi's hull has been broken, but her spirit has not. The second letter was to his wife. No one knows exactly what he wrote. The letter was never recovered, but officers who saw him writing it later recalled that his hand was steady and his face was calm. Inoguchi sealed both letters and gave them to his adjutant, with instructions to deliver them to the destroyers if evacuation became necessary. Then he returned to the bridge. At 5:30 p.m., the forward momentum stopped. The last functioning engine had failed. Musashi was dead in the water. The list to port was now 15 degrees and increasing by roughly 1 degree every 10 minutes. Commander Kato reported from below that nothing more could be done. The ship was flooding faster than any human effort could stop. Inoguchi nodded. He ordered the signal flags raised. The message was simple: prepare to abandon ship, 6 o'clock to 7:15. What followed was one of the most orderly evacuations in naval history, a fact that is remarkable given the circumstances. The ship was sinking. She was listing so severely that walking on the deck required holding on to fixed objects. The sea around her was covered in a thick layer of fuel oil, and night was falling. The executive officer organized the crew into groups. Wounded men were lowered into life rafts first. Sailors who could swim were instructed to jump from the starboard side, which was now the higher side, and swim toward the destroyers. Officers distributed life jackets. Those who did not have jackets were given anything that could float: wooden crates, empty shell casings, pieces of decking torn loose by bomb hits. The 3 escort destroyers moved as close as they dared. Yukikaze positioned herself barely 200 meters from Musashi's starboard beam. Her crew threw lines, lowered cargo nets over the side, and hauled oil-covered survivors aboard by hand. Kiyoshimo and Isakaze worked the other side, picking up men from rafts and pulling swimmers from the water. It was dark by 7 p.m. The evacuation continued by the light of handheld lanterns and the glow of fires still burning aboard Musashi. Captain Inoguchi did not join the evacuation. He was last seen on the bridge at approximately 7:10 p.m. Several officers pleaded with him to abandon ship. He refused. According to the testimony of Lieutenant Hosoya, who was one of the last men to leave the bridge, Inoguchi simply said, "This is my ship." He was never seen again. 7:35 p.m. The end. Musashi lists past the point of no return. The port rail dips below the surface. Water rushes across the main deck. The bow, already submerged for hours, pulls the rest of the ship forward and down. The stern rises. The 3 massive propellers, each one taller than a man, emerge from the water and spin slowly in the open air. The sound of tearing metal is deafening. Internal bulkheads collapse in sequence. Ammunition magazines flood and implode. She rolls to port. The superstructure hits the water. The mast goes under. The stern lifts higher. For one long, terrible moment, Musashi stands nearly vertical. Her stern pointed at the darkening sky. Her bow already touching the seafloor 800 meters below. Then she slides under. The surface erupts. A massive shockwave of displaced water radiates outward. A column of steam and smoke rises into the night sky, forming a mushroom-shaped cloud that survivors later said looked exactly like what they had heard about the new American superbombs. Oil fires ignite on the surface. The water glows orange. And then silence. Where the mightiest battleship ever built once floated, there is nothing. Only oil debris and the sound of men calling to each other in the darkness. Of the 2,399 men who served aboard Musashi, the destroyers rescued approximately 1,376. More than 1,000 perished, including Captain Inoguchi. The news reached Tokyo before midnight. Admiral Toyota received the report in his office. He read it once. He read it again. Then he placed it face down on his desk and sat in silence for a very long time. Musashi, the symbol of Japan's naval invincibility, the ship that was supposed to be unsinkable, had been sent to the bottom by aircraft. The reaction across the Japanese military was profound. Senior officers who had built their careers on the doctrine of battleship supremacy were forced to confront an undeniable truth. The age of the battleship was over. It had been over for years, and Japan had spent a staggering percentage of its limited industrial resources building 2 of the most magnificent, most powerful, and ultimately most useless warships in the history of naval warfare. Musashi never sank an enemy ship. She never fired her main guns at a surface target in anger. She never fulfilled the purpose for which she was designed. And her sister Yamato would meet an almost identical fate 6 months later, sunk by American aircraft on April 7, 1945, during a one-way suicide mission to Okinawa. Yamato took 3,055 of her crew with her. Together, the 2 super battleships cost Japan the equivalent of billions of dollars in modern currency, consumed steel and resources that could have built dozens of submarines or hundreds of aircraft, and contributed nothing to the defense of the homeland. The war ended 4 months after Yamato's sinking. Japan surrendered on September 2, 1945. But this story has one final thread, the part that history books rarely mention, the part about what happened after. What happened to Dale Birchfield, the Kansas farm boy who spent the night before the battle inspecting torpedoes by flashlight? What happened to Charles Momsen, the man who defied the Bureau of Ordnance and fixed the weapon that killed Musashi? What happened to the 376 Japanese survivors pulled from the oily waters of the Sibuyan Sea? And what was found 70 years later when a billionaire explorer aimed his deep-sea cameras at the ocean floor and discovered Musashi's wreck exactly where she had fallen? The final chapter is coming, and it will change how you think about everything you have just heard.